All right, so this is our last problem of this problem set. And we have something in this form. So we have on the left-hand side, we have t times e to the power of 4t. So this is kind of a mix of the previous problems we have seen. All right, so let's take a look. If I'm looking at this t, the first part, from the previous problem, problem number 4, and also the first problem, I would guess that my particular solution will have a form of a t plus b. Okay, so this, and if I'm looking at this exponential part, then from the second problem, or the third problem, I would guess it will have the format of c times e to the 4t. So which one is it? And the answer is both, actually. We're going to multiply these two, and we're going to call this to be our particular solution. So this, let me rewrite this. So our particular solution, our guess is that it's going to be, it'll take on the form of a t plus b times c e to the 4t. All right, so if I distribute this, we get act e to the power of 4t plus bc e to the power of 4t. So we have lots of constants, and let's just say that a times c, that's just going to be, let's just give it one constant. I'm just going to call that a, t e to the 4t. And also b times c is just another constant. So I'm just going to call that as b to the power of 4t. Okay, so this is our general or particular solution. Let's go ahead and find the y prime. So we're going to have to use some chain rules here, and that'll get us a e to the 4t plus 4at e to the 4t. That's just differentiating this first part. Plus, differentiating the second will get us 4b e to the power of 4t. Okay, let's find a second derivative. This is going to be, all right, so 4a e to the power of 4t, that's from differentiating the first term. Second term, we're going to have to use the chain rule, so that's going to be 4a e to the power of 4t plus 16 at e to the power of 4t. And I'll keep going, so it's going to be 16 b e to the power of 4t. Okay, so this is what we have, and let's just plug in all of this into our original equation, and I'm just going to erase this part instead of rewriting the whole y prime. Okay, and I'm going to continue, so I'm going to continue to plug in, now plugging in the y prime. So I have to multiply this by -4. So I'm going to continue to write it underneath. So that's going to be -4a e to the power of 4t minus 16 at e to the power of 4t minus 16 b e to the power of 4t. All right, so far everything seems to have canceled out except for the very first term. We still have to multiply -12y. So, all right, this is our original equation. So let's multiply that. So that's going to be underneath here. So -12 at e to the power of 4t minus 12 b e to the power of 4t. And we know all of this would equal to t times e to the 4t. All right, so as we've seen, all of these terms are going to get canceled out. What we're left with is negative 12at e to the power 4t. That is this one right here. And then we also have plus 4a minus 12b e to the power of 4t. That's going to equal to t times e 4t. All right, so we can get to some deductions here. First, we know that negative 12a must equal to 1. Okay, that's from these two parts being equal. So here we can get that a equals to negative 1/12. All right, and this part should equal to 0 because we don't see any term with e to the 4t alone. So we have 4a minus 12b, this should equal to 0, and we can plug in this a value, and if you do the math, this should get us to the b value of negative 1/36. All right, so that's it. So after we plug in a and b values to here, that's going to be our answer for number 5.